Take a meter stick and hold it up level with your eye. Now take a finger and bring it closer and closer until you cannot focus on it anymore. Measuring this distance gives you what is called the near point. In a normal eye, this distance is 25 centimeters. Light reflects off of an object and travels to the eye. The light rays are refracted through the cornea and the lens, and then they are focused on the back of the retina at the focal point. The far point is the furthest distance that an eye can focus on an object. For a normal eye, this distance is infinity. Infinity in this case simply means that when the light rays bounce off of an object and travel towards the eye, they will enter the eye parallel to each other. When these rays are refracted through the cornea and the lens, they are focused on the back of the retina at the focal point. The important thing here is that the image from both the near point and the far point is focused at a single point onto the retina, and the image is seen clearly. Of course, not all eyes are normal. Myopia occurs when the image is focused in front of the retina. In this case, the far point is not at infinity, but at some finite distance. In other words, the eye cannot focus on images that are very far away and is commonly called nearsightedness. The most common cause is that the eyeball is elongated. So the rays coming in are focused where the retina should be, but since the retina is further back, the image appears blurry. Less commonly, the lens of the eye can be too strong. This causes more refraction of the light rays, resulting in the image being focused in front of the retina. A person who is nearsighted can see nearby objects, but has trouble focusing on objects far away. The focal point is in front of the eye, so it needs to be focused further back so it reaches the retina. To fix this, we use a concave corrective lens in front of the eye. The concave lens spreads the light rays coming in before they hit the cornea. This initial divergence causes the light rays that are refracted by the cornea and the lens to focus on the back of the retina. To determine the power of correction needed, you must know the person's far point. On the other hand, sometimes the eye is too short. In this condition, the near point is greater than 25 centimeters. As a result, the light rays entering the eye are focused on a point behind the retina. So up-close images are difficult to see. This is usually referred to as farsightedness. A farsighted person has trouble focusing on objects that are close. The rays of light coming in are not bent enough to focus on the back of the retina. In this case, we can use a convex lens in front of the eye. The convex lens converges the light rays even more, forcing them to meet closer to the front on the retina. To determine the correct power of the lens here, we need to know the person's near point.